Other things that you could have been doing, so thank you for coming to this. I'm going to be talking about Spring a bit and serverless a bit, and a bit about what both can do together. My name is Dave Syer. That's my Twitter handle if you want to have a reaction. I hope it's a positive one. So I work on the Spring team, and I've been responsible for various things over the years. Has anybody ever used Spring Batch? A few people. So that was that was the first thing I did. And over the years, I've contributed to quite a lot of different parts of Spring, including most recently Spring Cloud, and before that Spring Boot. So this is a little bit about what I've been doing for the last year or so, and also mainly focusing on serverless. What does it mean? It means functions. What kind of platforms are out there? What can you do? Including one that we've been working on ourselves at Pivotal called Riff, which I'll hope to have time to show you. And the demos that I do will be using Spring Cloud Function, which is a newish project. We just had a release candidate for 1.0. Anybody in the audience already using serverless, already playing in any, just prototyping, testing, lambdas, anything? I can't really see, but I can't see any hands. There's one. Okay, fine. Yeah, so it's new, right? That would explain why nobody's done it. Let me try and explain why you might want to do it. So what is serverless all about? If you look on at least my Twitter feed, a lot of people are bickering about what it means and whether serverless is a stupid name or not, which it clearly is, right? Because there are servers. But I think it's useful to have a label, so let's just work with it and see what we get out of it. So to me, this is sort of impressionistic view of what serverless means. It has a lot to do with being event-driven. Other things are event-driven, but in serverless, sort of that's the way that you think about your code. There's an event that triggers it, and you maybe create events, trigger further events downstream. Very important to quite a few people who do the serverless thing is this idea of scale to zero. So generally speaking, that means it's not a new idea, right? And it's not just serverless platforms that do it, or maybe we should redefine the platforms. But scale to zero means if your code isn't running, then you're not using any resources, which in a platform like AWS, Amazon Web Services, means that you are not being charged for it. So there's billing per event, basically. So that, I think, is probably more important to most people about the billing than the actual resource utilization, but they're sort of correlated. Okay, and sort of slightly orthogonal to that, because what serverless is first and foremost, it's an abstraction. And like any abstraction, it has compromises and, pros and cons. So one of the pros, one of the best things about it is that you really do get to focus minutely on your business logic. There's nothing else for you to do. There's no, in a serverless platform, there's no way to know. In principle, in practice, things leak, of course, but in principle, this is sort of in the pure view of serverless as a sort of philosophy. Everything is business logic. You process an event, you transform it, you do some business logic, and you emit another event or events. And for those of you who know Spring, how many people use Spring? I'll get a few more hands this time. Yeah. For those of you who know Spring, this is sort of very familiar, because this is what we've been doing with Spring since the beginning, 2004, whatever it was. We've always had a very clear mission that what we do is enable developers to write business logic and forget about the rest. And so serverless, is a new movement, a new philosophy, but it's not a new concern for Spring developers. So we think that maybe, if anybody's using Spring, they might recognize this, and therefore Spring ought to be able to help you if you want to do it serverless with Spring. It should be something that's easy. And the last bullet is another thing that's quite important to some people, but not everybody. I think, to me, it's become increasingly important. The more you use one of these platforms, the more you get addicted to it. And there's a message behind that as well about vendor lock-in, because they all want you to use more of the platforms. And that's really to do with the sort of native services that are available in the platform. So in AWS, you've got HTTP gateway and simple message service and Kinesis and blah, blah, blah. Loads of platform services. In Google Cloud, you've got the same things. In Microsoft Azure, you've got the same things. And, different flavors of the same thing. Google and Microsoft actually sort of specialize in heavy back-end computing, like AI instrumentation and AI libraries and things like that. AWS has some of that, but it's not really the speciality. So each platform comes with its own services. And if you wanted to do this kind of thing without using one of those platforms, if you didn't want to or couldn't use Amazon, Google, Microsoft, whatever, what would that mean, right? And that's one of the questions that we've been thinking about in the Spring team, and also especially in the Riff team. So one of the questions everybody will ask is, well, what can I do with it? And I think, it comes down to pretty much two use cases. People do webhooks, and they do background jobs, and that's it. I mean, specifically business terms, there are lots of different applications of those two patterns. Let's call them patterns instead of use cases. Image processing, whatever. If you do a Google for CNCF serverless white paper, you'll find the link that I'm pointing to there, and that's a very interesting collaborative Google Doc by a bunch of people from the Cloud Native Computing Foundation. That has a nice big section with a list of concrete use cases, what people are actually doing with serverless. But what it comes down to is basically glue code. It's kind of hands-free integration. You don't know or need to know about what physical things you're connecting to. You just write some logic, some event processing logic. And one thing I'd like you to notice about those patterns, those scenarios, is that they are not particularly latency sensitive, right? A webhook is probably something that I'm interested in. Maybe I want to know when somebody comments on my GitHub issues. It doesn't happen, hundreds of times a second. It happens, once a week or twice a week or something like that. So I'm quite happy for that to happen at any time during that week. It's not latency sensitive. I don't care if it takes 30 seconds or a minute even to run. It's fine as far as I'm concerned. Except, of course, that I'll be paying for it if it's in one of the platforms. So that's just an observation. And it's an important observation because when we start thinking about running Spring in a serverless platform, some people just laugh and say, no, that's a really stupid idea. Why do you want to do that? And the reason they say that is because the JVM is, it's not optimized for cold starts. If you start a JVM and load all the classes and create dependency graphs and instantiate them and everything, it takes a bit of time. It doesn't have to take a long time, and I'll show some demos in a minute, which will kind of underline that point. But people have questioned whether Java is a proper thing to do in serverless, and it is. It's fine, right? If you want to use Java, you can, but there are other options. If you want to use, Golang, Node.js seems to be the one that everybody supports. Python is also popular. That's fine, and you probably will get faster cold starts from those things, but it might not matter. And so if you're comfortable in Java, what I'm trying to do with the Spring Cloud Function project is just make it as easy as possible so that you don't have to suffer any, boilerplate nightmares. Okay, here's some proof of life, if you like. Amazon has this Lambda thing that is function as a service. It has a UI, a web UI. It also has an API, like everything in AWS. And the API is connected to a command line interface. So if you wanted to write some code and deploy it to Amazon, you could automate it. It's horrible. It's not a nice thing to do, but once you've done it, you sort of learn how. There are some tools out there that make it easier, not from us, other frameworks that are sort of more build time, more sort of build tool oriented. Google Cloud Function has an interface as well. Looks like this. It looks very similar. You can type some JavaScript into a text box if you want to and make that your business logic. That's how easy it is, right? You can really quickly get some business logic running and up in the cloud and not care about, whether it's healthy or not, because everything's monitored and everything's restarted if it fails, and it's all always alive, or always alive if it's processing messages. Microsoft Azure has, another very similar looking interface. It's a lot busier actually, the Microsoft one, but it's got the same sort of basic features, and you can deploy functions in Java to Microsoft Azure. The one that I've been working on, this is kind of a cheat because we don't have our own UI. This is just a Kubernetes dashboard showing, actually not even a Kubernetes dashboard, is it? It's a Google Cloud Platform Kubernetes cluster showing the cluster running. So we run Riff on a Kubernetes cluster, which means that it's a good way, and there are a lot of other platforms that do this, but it's a good way to create your own serverless playground, something that you could run yourself, and you could run it in your own data center, you could run it on Amazon or Google or whatever. And I'll show you, hopefully I'll have time to show you how that works later. So here's a possibly not complete list of serverless providers. There's the usual suspects: Amazon, Google, Microsoft. IBM has one, Oracle has one, also a bit like Riff, actually, sort of container-based. They don't have a service for it at the minute. I don't think it's you run it yourself. The ones with the J are native Java, or they have support for native Java. The other ones, by and large, you can run Java because they're sort of container-based. You can always, create a new container, a custom container with a Java image in it and run it, and it'll work. But it's a little bit, there are more hoops to jump through, and there are no JVM-specific features in the platform. Okay, so if you wanted to run functions in Java, this is the way I think about it. The first thing we thought of when we were thinking about Spring support was Java Util. The JDK actually has functional interfaces built into it, so they're common language for everybody. So this is where we started thinking. We started thinking about Java Util function and its cousins, consumer and supplier. And if anybody was at Dieter's talk just before me, he was talking about Spring Cloud Function. It's the same patterns there, basically: message processing, event processing. You've got processor, sync and source in Spring Cloud terms is function, consumer, and supplier. So that's where we started as our programming model. And this is where we ended up. So the idea is that you can have a normal Spring Boot application, with its main method, like everybody's used to these days. And any bean, so @bean, @component, how XML if you want it, however you want to define your Spring beans, any bean which is an instance of function, like this one is, on the slide up there, which is just a simple transformation of strings. It's, a string is uppercased. Any bean of type function is exposed in a special way. Okay, what in that special way will depend on which platform and which adapters are in the application. So in the sort of normal Spring Boot way, we try to detect what's there and use it. Probably one last thing I want to say before I move to a demo. We also, for people who don't like Spring or don't need Spring, we also support plain old functions, which just means you don't need any Spring dependencies at all. You can just define beans of type function. We'll happily suck them up and register them with our function registry. And then you're basically able to benefit from all of the machinery that Spring Cloud Function provides. So I'll show you how to run it. Okay, I'm going to create a new. I can't make that font any bigger, but I'll make sure that the code is big when I get there. I'll make a new Spring project. I'm doing it in Eclipse. You could do it with start.spring.io, from the web UI. You could do it with IDEA. You could do it with NetBeans. I'm going to put something cloudy in there that says Cloud Bootstrap because Spring Cloud Function isn't yet supported on Initializer. There's a pull request open, but it hasn't been merged. So then I've got a function ready project. To make it actually a function, I'm going to, hopefully that font's big enough for everybody. I'm going to change Spring Cloud Starter to Spring Cloud Starter function web. Okay. I'll do that manually because the checkbox isn't there yet. So then in my Spring Boot application, I'm going to make a bean like I had on the slide. Wait for Eclipse to come back from whatever it's doing. There we go. Function string to string demo return value hello. I'm just going to say hello to whoever comes in, all right? And that's all I need to do. So then I'm going to run that, run as Java application, Spring Boot application, doesn't matter. And when it starts, you can see a couple of things happening. You can see Tomcat. So that's because I used the starter function web. So I've got an adapter in there that means that I exposed my function as an HTTP endpoint, just so I can play with it locally, basically. Or I could use that to, create applications, mini applications, whatever I want to do. Here's a terminal. Is that big enough? Make it a bit bigger. How big can we go? Curl, localhost, 8080, and I'm going to put in Riga. And I need to tell it what the content type is. Content type text plain and hello Riga. All right. So my function has been hooked up to a web endpoint, and so what you will probably be able to extrapolate from that is that we can hook it up to a variety of things: web endpoints, message brokers, Amazon lambdas, Azure functions, whatever the platform supports. will take your function beans and hook them into it. So yeah, let me show you. There's in Spring Cloud Function itself, so this is AWS Lambda. So this is AWS, this is the Lambda. Uppercase. So I have a function called uppercase. This is the sample app from Spring Cloud Function. It's called Function Sample AWS because we have the build steps that you need to add the AWS class path and build steps, and I can test it. Okay, so they have a little test button there, and guess what? It's a little bit slow because it was a cold start, right? So let's have a look. This isn't the same function I just wrote. This one is an uppercase. It does a JSON object, and uppercase is the value. It took 5,600 milliseconds. Okay, 5 seconds to start Spring App. It's kind of sucky, actually. It's not a particularly fast place to start Java. But the good news is, if I do it again, it's only 7 milliseconds. All right, I would still build for 100. That doesn't change. But Amazon caches. Look, that's even less than a millisecond, right? Amazon caches the containers. So warm starts are really not expensive at all. Cold starts, a little bit more expensive than I would like in Amazon. Microsoft, here's the same thing in Azure. There's the same function, but adapted for the Azure platform, so the build step, the building the jar file is slightly different because you need the Microsoft SDK instead of the Amazon. There's the function, uppercase. The Amazon web UI is very slow. But the functions normally run actually pretty quickly once you get them warmed up. So there's a function here. I can test it. It has the same. I'm just showing you it has the same basic features, right? So I can run a little test app here, and the logs will show up underneath. Let's see if I can extract that. Yeah, I'm connected, so maybe I didn't press that. There we go. This might take a while, actually, because, and this is a lesson, right? So it could be that the smallest amount of time in this whole cold start is actually taken by the JVM and Spring, because there's lots of other stuff that needs to happen here. A container has to be fetched from somewhere. Resources have to be provisioned. It has to be started. The bytes are moving around, and that isn't free, and takes a while. Okay, so it came back. Foo. There's no. I can find the log somewhere. You'll find it's a sort of similar startup time to the Lambda one. So a few seconds for a cold start, and then 0 for the warm ones. So that's a little bit disappointing, given that this one just started up in 2 seconds, 1800 milliseconds for Spring to start and that's starting Tomcat as well. I didn't need Tomcat in the platform example. So to show you what the raw startup time would be, I'm just going to do Spring Cloud Function context. All right, so that's without any adapters, any decorators that connect it to anything. And then if I start that, of course it just immediately stops because it doesn't have anything to do. But that takes 700 milliseconds. And this is my crappy laptop. This is not any powerful machine or anything. If you put that on a decent size, floor-mounted data center server, that will be 300 milliseconds or something. It can easily go more than twice as fast as that. And that's a cold start. So that's, Spring, it has started Spring, by the way. There's an application context. Spring Boot, everything is happening in the background there. It just hasn't started Tomcat. So that's one sort of observation on JVM startup time. It can be quite fast, actually, and the platforms don't necessarily take advantage of it. So what's happening, in case you haven't figured it out, is they don't give you enough resources, so they throttle the CPU, essentially. A JVM, not just Spring, a JVM app, if it's doing lots of things, loading classes, compiling, garbage collecting, all of those things use threads. And so if you'd only have half a CPU, then those threads are useless. If you have 4 CPUs, you can start up relatively quickly. The JVM never was really supposed to start quickly from cold. Maybe that could change, but that's not the way it's designed. So in Amazon, what they do is they give you one knob. So let me show you. They give you one thing that you can configure, and that is somewhere here, basic settings. You can set the memory. And so you can go from, I think, 128 megs up to 3 gigs. And mine was set to 1.5 gigs. And the reason I set it like that, I can tell you a story on the slide. The reason I set it like that was, I think, the next slide. Cold starts on AWS, it's easy to measure them, right? You just change that memory setting and see what happens. The horizontal axis on both graphs is the same. It's memory, so it goes from 0.5 gig to 3 gigs on the right-hand side. The top graph is startup time, and you can see there's quite a dramatic improvement. If you double the memory at the beginning, it starts up twice as quick. Okay. And so the reason for that is because when you ask for more memory, they give you more CPU. They don't tell you what the equation is. They don't tell you, if you have 1 gig of memory, then you'll get 2 threads, but it's 2 CPUs, but that's probably roughly what it is. And then as you increase up to 3 gigs, it starts to flatten out a bit. And the bottom graph is the billing calculation. So how much will you be charged for? They charge per gigabyte second. And so there's a dramatic change in the startup time, but it doesn't actually cost much more. It's around about the same, actually, for twice as much memory at the bottom end there. So there's this sort of sweet spot here around about 1.5 gigs, which is where I was playing my demo, where the cost isn't much more, but the startup time is roughly 3 times faster than the cold start with 0.5 gig. With less than 0.5 gig, it gets even worse because they throttle the CPU. So Amazon probably could improve that if they wanted to, right? If they thought that people were going to use Java more, they would, because I don't need those threads after I've started up. I promise not to use them. Just give me 4 CPUs for a second, and then you can have them back again. So I don't know whether they'll listen to that, but they could do better. And then probably, all the clever stuff they do with the other things, moving the container bytes, getting the resources in place, will actually count for something. Okay, so that's a quick picture of Lambda. There was one other thing I wanted to show. So in this app, I started up on my laptop. I started up there in 700 milliseconds. I could show you something else. If I do Spring Boot DevTools is what I want. DevTools, there we go. If I had DevTools, normally we make it optional. How many people use DevTools? How many people never heard of it? A few. Okay, so this is cool. I'm not going to use it in the way it's intended. I'm going to use it to make a point here, but what I need to do is I need to stop this application from exiting. So I'm just going to do new scanner. Somebody might have to pair program with me here. New scanner of system.in. Next line, is that what you do? Yeah. So I think what will happen now is when I run that, it will no longer exit immediately. Okay, so it's still running. The first time it started up, it took about the same. Okay, 800, 900 milliseconds. If I did it again, it would fluctuate. But this is what's interesting. If I edit the file and save it again, it gets recompiled. And when it restarts, look at that, less than 200 milliseconds. And that is a significant improvement, right? That's like a factor of not 10, but 8 maybe. It's not bad. At least 5. So what that's telling you is the difference between the cold start and the warm start is what DevTools does is a class loader trick. It creates a new class loader. It restarted Spring. It restarted the whole application there in less than 200 milliseconds, but it did it in an isolated class loader. Threw away the old one, created a new one, started the Spring application in it, and it starts much quicker. And that's actually a pretty general result, that you can get very fast warm starts if you can warm up some of the caches, basically. So what's happening, I can't prove it, but I think what's happening here is it takes time when the JVM starts up. It takes time to read through all the jar files looking for bytes, right? Find a class by name means you have to look in all the jar files, find one which has that entry, scan to where it is, pull it out, convert those that input stream into a byte array, convert the byte array into a representation of a class, a syntax tree, and all of that takes some time. So what I've found when I've measured these things, there are some benchmarks. If you look in my GitHub repos, you'll find benchmarks. There are some nice graphs of classes loaded versus time to start up, and it's quite a tight correlation. So basically what that tells you is more features, more classes loaded, longer startup. So the more features you want, the longer it takes. And what I'm showing, I guess, with the warm startup is that you can shave quite a lot of time off that if the classes are already loaded, and the reading the jar files has been done, whatever that entails. I'm not really sure. Okay, so back to the slides. What is Spring Cloud Function in a nutshell is sort of these are the mission statements, if you like. What we want is for Spring developers to have all the benefits of serverless. But if you want to or need to, you can do dependency injection, integrate, connect to a Redis database, whatever you want to do. And also auto-configuration from Spring Boot. So you can add features by just changing the class path. And also, I think more importantly for me, all the build tools that you're used to, all the processes, testing, continuous delivery, run the thing locally on your laptop, all of that works with Spring Cloud Function, and that is a little bit of a challenge for the native serverless Java platforms, because they have their own SDK. They don't really concentrate on they concentrate on getting it into the platform and getting it running. They don't think about the developer experience. So that's something that Spring is quite good at. So for Spring devs, it's familiar, but it's just a slightly new programming model on top of the old one. And for people who don't know Spring, then you can just write Java in Java Util function, and you've basically decoupled that business logic from all the other things that could happen to integrate with the outside world, HTTP, messaging, AWS Kinesis things, events. And it gives you a uniform, as much as possible, a uniform programming model across serverless providers. That is a little bit of a pipe dream, because everything leaks. Basically, the platforms have, their own APIs and their own SDKs, and the details. If you want to consume those natively, then you're probably going to have to explicitly do that in your code. We can protect you a little bit. Actually, one of the things I didn't mention was, as well as function of string, you could also do function of message of string, and that has a special. So I won't finish this demo, but message is a Spring messaging abstraction. So you can have message of string, and then that will give you the string as the payload, and then metadata in headers. So in Amazon API gateway, for instance, it will give you the HTTP headers. So that could be a useful trick. And then the other thing is the reactive side of things. So this is partly driven by the fact that everything in Spring these days has a parallel universe of reactive implementations, and partly because serverless is about events, and events are not just request reply, right? It's not just like HTTP. The events are about streaming. You could have, 0 or more, 0 to infinity events in, 0 to infinity events out. You've got stream in, stream out. And the way to express a stream is as a publisher in Java, so reactive streams publisher. They have this thing in Java 9 as well called Flowable, which is the same API. So Flux and Mono are two implementations of publisher from Project Reactor. We also, in Spring Cloud Function, I'm sorry, I jumped a slide there. In Spring Cloud Function, we support that by giving you the option of implementing function of publisher to publisher would work as well. Here I've got Flux to Flux. And so one of the reasons you would do that would be if you want to, filter or manipulate the streams. So in this case, I've got a filter applied to it. So I'm saying anything which is not rude will be uppercased. I'm not going to do anything with rude words, sorry. I don't accept rude words. So this is a function which has, an infinite stream as the input and an infinite stream as the output, but with a smaller number of events in the output because I've filtered out the rude words. And that's just the beginning of what you can do with Flux and all those nice operators. Okay, this is a picture that sort of underlines what I was saying in words earlier. The user function, that's what you write, that's the Spring application, is then adapted using some adapter to a serverless provider. Might be AWS, might be Microsoft. OpenWhisk is another one we support. Oracle has an Oracle FN. They have their own Spring Boot function, Spring Cloud Function support. So we didn't do it there. We didn't do it in our project because they have one. Project Riff, which I'll hopefully have time to show in a minute, it sort of does need one. Yeah. So it has an adapter which. Because the way the architecture of Riff has function invokers which listen on gRPC for streams of events. And so we need a gRPC server that will listen to the stream and then delegate to the event. So I guess that's the adapter in that case. But that lives in Riff. It doesn't live in Spring Cloud Function. I suppose that's the best way to put it. And Spring Boot is at the bottom of the stack because we're taking advantage of all the neat auto-configuration features in Spring Boot. Okay, so you can, schematically, you can have HTTP or message or other kinds of input, and the way that your function gets triggered depends on the adapter and whatever you've configured. So, Spring Cloud Function. I've shown you a bit about the programming model. So it's beans of type function, consumer, supplier. with Flux, Mono, or Publisher, and also Message is a special signature, I suppose, of the functions. So we have this component scan for functions. We scan the same way we scan for any components, but we specifically scan for functions. So you can do that with no Spring dependency. So the app that runs your function is a Spring app, but you didn't have to include any Spring dependencies in your function itself. We also have this sort of, I don't know if it's I don't know how useful this feature is really, but so it could be just a trick, but it's something that the other platforms do with Node, for instance. You can type your JavaScript function into Amazon or Azure, and it will run it. So we have this thing where you can do that with Java. You can just type the function body into a text box. We don't provide the text box, we provide the compiler. So that basically compiles the string and makes it into a Spring bean so that it can be registered with in the same way that the other beans are. Then we have a set of features I haven't mentioned but is motivated by that demo I did with the dev tools. So if you have an isolated class loader where your functions are running, that's a good thing for a number of reasons. One of which might be those you get a warmer start, a faster cold start because it's warm essentially. Another reason might be that you want to have different dependencies for your function than for the driver app. So the driver app has Amazon AWS flavor, but the function wants to connect to something else like a Redis database, like I mentioned earlier. So then we have adapters. We have the Spring MVC one that you saw. We'll probably have a WebFlux one in the next version. Because at the minute we're supporting Spring Boot 1.5 and 2.0, so the common denominator is Spring MVC. Spring Cloud Stream for messaging, AWS Lambda, Azure Riff, other serverless providers, including OpenWhisk. So there's an adapters section in the GitHub repo. So yeah, I just thought this is the end of the slides. I'll try and do a quick Riff demo before I finish. Just some things, random things that we've learned. We've had quite a long incubation period for Spring Cloud Function. We did start it over a year ago, and it's sort of been ready for a long time, but I don't like releasing something until it's been used. And I wasn't getting a lot of feedback. I know people are using it on AWS. A few people have actually, started bugging me now, saying, when are you going to release it? Isn't it time yet? And I think it is. So we've had a release candidate. The reason it had a slightly long gestation was because I was waiting for, feedback. And so some of the feedback we got led to features, and a lot of it came from Riff, just the fact that we were using it in Riff. And so we've learned, and I've done a lot of research on JVM cold starts and all the benchmarks that I haven't. I'll quickly just find that repo for you in GitHub so that you can see what I mean. GitHub.com Syer Spring Boot Startup Bench is what it's called. If you there you go. If you can. See that at the back, and so in there's some benchmarks, lots of data. There's also the graph that I was talking about is somewhere here. This one, no, not that one. So there's a click through from that top level to a sub project here, which has got, there we go, the graph of classes loaded to startup time. And there's much better correlation, for instance, than with beans, but there's some correlation in both. There's actually more data than that. There's another graph somewhere. I'm not seeing it, but if you click around, you'll find another one with even more points on it. So there's probably 60 or 70 points on the most recent version of that. So I've done a lot of research on that now. Spring on its own is not actually slow at all. There's probably still some optimization to do. I mean, one of the things that we've discovered, one of the learnings that I haven't explicitly called out there is that Spring Boot 2 is a lot faster than it would have been if I hadn't been doing these benchmarks, because every time you do a benchmark, you expose a new possibility for optimization. So we will probably continue to optimize because we care about this, but on its own, it doesn't do very much, right? So it's all about the number of classes you load, the number of features you use. On the other hand, AWS, Lambda containers, whatever you do, your JVM isn't going to start all that quickly. It's nothing to do, I don't think, with Spring. It's just the CPU throttling that they apply. But you can start warm JVMs much quicker because the classes are already somewhere loaded, memory mapped. I don't know what happens, but it's quicker the second time. You can see that, by the way, sometimes in Spring integration tests. If you have a suite of tests, the first one takes a long time, the second one and subsequent ones are faster, not just because of the caching, because even if you have a dirties context and you start the context again, they're faster. Subsequent restarts are faster. You can see that in the Pet Clinic, for instance. So the point I made at the beginning, functions are glue code, so they're not really a good fit for latency-sensitive use cases anyway. If you cared about the, even the 90th percentile, I mean, it depends on how many requests you've got going, right? But if you care about the tail of your latency, then they're probably not a great tool. But scale to zero is a powerful concept. It's not, I said this already briefly, but it's not limited to serverless per se, or maybe we should just rebrand some of the other services as serverless. So Google App Engine Classic, for instance, which I've used for years, always scaled to zero because they didn't want your app running if you weren't using it. So it's always been a feature, and that's a full app. That's not just a function. And then the last thing is about platform services, and people, get more and more addicted to those. Actually, I should tell a story about that while I'm here. This is my take on vendor lock-in, right? It's a thing. And my experience of it is this: everybody has a phone, right? I have a phone with photographs and backups and personal data of all sorts are on there, and it's all backed up to the cloud by Apple, and my photos are all backed up to the cloud by Google. And both Apple and Google are constantly asking me telling me that I'm running out of space. I'm running out of space because I'm mean and I only take the free tier. And it's not expensive, right? It doesn't cost much to buy more storage, so why don't I do it? So I've tried to analyze that, and I've decided I don't do it because I don't like being locked in. I can't see a way out. If I buy storage from Apple for my iCloud backup, I can't see a way to move it from there to anywhere else. And if you don't give me a way out, then I can't bring myself to buy it. So I think the same thing might happen with platform services. It would be really nice to use AWS services, but I don't want to get addicted to them. I want to protect myself a little bit. And so what I need, I think, and this is what hopefully you'll agree, this is the way that enterprise developers think and enterprise purchasers. They want to buffer themselves, and buffering means abstractions, and Spring Cloud Function and Riff, I'm not going to have time to show it now, am I? And Riff is an interesting abstraction because it gives you at least the machinery, the opportunity to create your own sort of in-house Amazon Web Services. I mean, you could even use Amazon SDKs if you wanted to just make it completely mix and match. But what people need, I think, is a platform that's flexible and extendable, so that you can build, what your real data sources are and your own integration points, and build those into the platform so that they can be consumed in the same convenient way that Amazon and Google and Microsoft make available to your functions. which at the end of the day, they're really just, it's just a YAML file or a JSON file. So they do everything with configuration. If you know what you're looking for, you can figure it out. So yeah, I just ran out of time, which is good because there are just some links left. I'll follow me on Twitter. I'll tweet a link to the slides so you won't miss any of the links. Spring Cloud Function there. Project Riff is there, which is our function as a service framework, I guess, platform thing, runtime. I didn't show any of this, but Spring Boot Thin Launcher is a nice concept as well, because it lets you change the class path of an app at runtime. So I could start with my Tomcat example, and I could switch it to Rabbit, and then switch it to Amazon, and I've done demos that do that, but I didn't have time to do it today. Spring Initializer was the thing I used to generate the project. Spring Cloud is the sort of parent project, umbrella project for all of the things that I've been talking about. And Project Reactor has its own website. It's another Pivotal sponsored project. Okay, thank you. I may have time for one or two questions, but come and talk to me briefly. I have to run and catch an airplane, actually, but if you've got a few minutes, I have a few minutes. Any questions? I can't see anybody, so it's a bit... You might have to shout, and somebody will bring you a microphone. There is one, okay.
Did you see any applications of cloud functions for high performance calculations? Like if you need 10,000 calculations, you launch 10,000 instances and something like that?
Yeah, I haven't tried it myself, but I think that is sort of one of the possibly core use cases of the function as a service. If you look in that CNCF white paper, you'll find examples like that, which is basically data analysis, data processing, that kind of use case. Dieter said he was going to do a Mandelbrot set as a demo. I don't think he got around to it, but that was an obvious thing to do. So yeah, I think that makes sense.